Let's look at ionic compounds that contain polyatomic ions. And the most important thing for doing this is we have to know what our polyatomic ions are. So spend your time, memorize them now, and it will make it much easier when we start writing formulas. And here are some hints. We're going to start by looking at the most common form of a polyatomic ion, which has the suffix -ate in it. So if we had NO3 minus, this is nitrate. Or SO4 minus 2 is sulfate. Or ClO3 minus is chlorate. And if we memorize the ate form of a polyatomic ion series, we can figure out the others. If we were to replace the suffix ate with ite, that means we're removing one oxygen. So if we had NO2 minus, it has one less oxygen than nitrate, so it would be nitrite. Or if we have SO4 minus 2 and we remove an oxygen, we'll have SO3 minus 2. Our suffix will go from ate to ite, so it will be sulfite. Or if we had ClO2 minus, our ate will go to ite, and this is chlorite. Now, some polyatomic ions have more than 2 ions in their series, like chlorate. We can see polyatomic ions that contain chlorine and oxygen, but have one more oxygen than the most common form, ClO4 minus. When we see something like that, we're going to put a prefix in front of the name, and our prefix is per. Per means one more oxygen. So per chlorate would have one more oxygen than chlorate, so ClO4 minus. We can have one less oxygen, and our prefix for one less is hypo. So one less oxygen than chlorite would be hypochlorite. And there's lots more polyatomic ions, but here are some hints to help you with memorizing them. Practice them all the time until you get them down. Let's look at some examples. Say we have NaOH. And the first thing we have to recognize is that we've got a positive cation and a negative anion, a first and a last name. But there are 3 atoms in this compound. That's because that is a polyatomic ion. We know Na is sodium. We have to remember that OH minus is hydroxide, so our name is sodium hydroxide. Here we've got NH4Cl. Again, there are 3 different types of atoms in there, but it's an ionic compound, so it's got a positive ion and a negative ion. And we should recognize that NH4 is the polyatomic ion ammonium, so our compound here is ammonium chloride. Now, this example has a whole bunch of different atoms in it, but again, if it's an ionic compound, there's a positive ion and a negative ion. And we should recognize C2H3O2 as the polyatomic ion acetate. So we have sodium acetate. And then we've got CaCO3. We know Ca is calcium, so there's our polyatomic ion. CO3 is chlorate, or carbonate, so we've got calcium carbonate. So let's look at it the other way. Let's say that we have the names and we want to write the formulas. So here we have potassium bromate. We know that potassium is K, and we know from the periodic table it forms ions with a +1 charge. If we see ATE, we should recognize it as a polyatomic ion, and we memorized bromate to be BrO3 with a -1 charge. So the 1 from the potassium is going to drop down here, and the 1 from the bromate is going to drop down here. So our formula for potassium bromate is KBrO3. Let's say we've got iron 2 sulfate. Well, this is a polyatomic ion in it, and it has a multivalent ion in it. But the multivalent ion kind of helps out a little bit because it tells you what the charge on the cation is. So we know the symbol for iron is Fe. The Roman numeral 2 tells us the charge on iron in this particular compound, so that's a +2. The ATE here tells us we're looking at a polyatomic ion, and sulfate is SO4 -2. We're going to take the 2 from the iron and drop it down here, and the 2 from the sulfate and drop it down here. But we know that when we write an ionic compound, those subscripts are the simplest ratio. So we're going to simplify that 2 to 2 to 1 to 1. So iron 2 sulfate would be FeSO4. All right, so let's do manganese 2 hydroxide. So our symbol for manganese is Mn. It's a polyatomic ion, the Roman numeral, or it's a multivalent ion. The Roman numeral tells us the charge, so it's a +2. We know hydroxide is OH, and its charge is a -1. Now, it's important in this particular case that we put parentheses around the hydroxide, because when this 2 comes down here, we want to designate that there are 2 hydroxides. We didn't need to worry about it up here because the 2 was simplified. So the 2 from the manganese is going to come down here, and the 1 from the hydroxide is going to come down here, and our formula is going to be MnOH2. Now let's look at that for a second. You have to have the parentheses there because that shows that there are 2 hydroxides. Really, that means that there are 2 oxygens and 2 hydrogens in the compound. If we write it without the parentheses, it's something different, because now it looks like there's 1 oxygen and 2 hydrogens. So we need to be careful about when to use those parentheses.